I want to look at today is a rule that we've been alluding to on a number of occasions up to this point, and that is a rule for integrating a function that is a composite function with a linear function inside. Okay? Functions that are composites of a linear function, and we use ax plus b just as our generic linear function. Okay? Now, we saw some of this when we were doing the problems where they gave you a function, they said, consider the derivative of this. So you found the derivative. And then they said, use that to integrate this. And what you ended up having to do is maybe you were missing a constant. So you had to multiply by something, but then on the outside you had to multiply by 1 over something to cancel that out. Well, all of that was kind of alluding to this idea right here. All right, the integral of a function that is the composite of a linear function equals 1 over a. Now a, notice this is a linear function. A is the slope of that linear function. Okay, or you could think of it as the derivative of the linear function. Okay, so it's 1 over a times the antiderivative of the original function. Okay? Now, we don't have a chain rule for integration, but this is about the closest thing there is to one. Okay? Like the chain rule with derivatives, when you're dealing with the outer function, notice here the inner function just stays the same. Okay? So, if I'm looking at this integral right here, the integral of 1 over the square root of 1 minus 2x dx, first of all, I'm going to rewrite that, or at least think of it in my head in terms of the integral of 1 minus 2x to the negative 1/2 power. Okay? Now, here it says to take the antiderivative in terms of that original inner function. In other words, act as though it's not even there really, and just take the integral of, I erased part of it, of this something to the negative 1/2 power. Now let me step over here for a moment. If I just had some random thing to the negative 1/2 power, and I was integrating, what would that equal?
Negative 1/2 u to the negative 1/2. Oh, no, you have to do that one.
Not quite. Think through your power rule.
What do you ask?
2x over 2.
Wouldn't it just
What are we asking?
What's the integral of something to the negative 1/2 power?
to the negative 1 is it's just you add 1, so then it's
2x to the
1
1/2.
over 2.
2 to the 1/2.
Yeah, okay, we add 1,
so it's 1
so it's to the 1/2
and then yeah 2
times the reciprocal of the new exponent. So yeah, it's times 2. 2u to the 1 over 2. Alright? Well,
Is this for every single time? Is the problem in the blue box just an example?
yeah,
It's not a model.
no, it's not a model for everything. I mean, this is just an example where here's our basic function, something to the negative 1/2 power over here.
Yeah.
So that's what we're thinking about when we're
Okay,
trying
so
to
then
do.
you're gonna plug in 1 minus 2x for u.
Exactly, okay? So here what I'm doing, I've got a 1 minus 2x in place of the u. So I have 2 times 1 minus 2x. Now it's to the positive 1/2 power. I've got the plus c here, but here's where this part comes in. Okay? What's the derivative of that inner function?
Negative 2.
Negative 2. The derivative of 1 minus 2x is negative 2. So I need to multiply by 1 over negative 2.
Why?
That's what the rule says to do. Okay? So notice here we found the antiderivative in terms of the original function. That's what we did here in red. But then we need to multiply that by 1 over.
The derivative of the inner function.
Yes. Okay? All right. Let's try another one. We're going to do a few of these here so we can get the hang of the idea. Okay?
That's all, okay.
First of all, here we're taking the integral of 2e to the 2x minus e to the negative 3x dx. Okay? So first of all, to simplify things for ourselves, I'm going to rewrite this as 2 times the integral of e to the 2x minus the integral of e to the negative 3x. Okay? Everyone with me so far? All right. Don't be afraid to rewrite stuff, okay? This will help you see things a little easier. So now we're thinking through, all right? I have 2 times this integral. So I'm thinking through, what is the antiderivative of e to a power?
E to the power.
E to the power, all right? So this is going to stay in terms of 2x. It's just the e to the power. All right? I'm actually going to, okay? Now, I also need to multiply that by a 1 over a. What's 1 over a in this case?
Same thing. No?
What do you mean?
E to the 2x. 1 over e to the 2x.
No, no, no. What is a?
Oh, 2e to the 2x. If you, the derivative of e to the 2x?
No, the derivative of the linear function inside. 2. So it's 1 over 2.
Why is it 2?
The linear function inside is 2x, right? So the inner function, e to a power, is the outer function. Okay? The inner function is this linear 2x. So the derivative of 2x is 2, so we're multiplying by 1 over 2. Okay? Now, of course, this part here is just going to simplify. The 2 and the 1/2 cancel out, so it just simplifies to e to the 2x. But we have this other half that we've got to deal with. Okay? So minus.
Negative 3. So 1 over, so negative 1/3.
Okay, good. We're going to have a negative 1/3 because the linear function is negative 3x and its derivative is negative 3. So it's 1 over negative 3 times, what's the integral of e to a power?
E to that power.
E to a power. All right, so e to the negative 3x. Okay? So, this, yep, we're going to simplify it.
1/3 to the negative.
Okay, good. 1 over 3. And since that's a negative power too, I'm going to throw it down here. E to the 3x in the denominator.
Can I go back?
And then that's plus c. All right, does that make sense? Realize we didn't exactly finish this one. That should have been a negative 1 times 1 minus 2x to the 1/2 plus c. I'm sure you knew that. Okay. All right, so is this starting to get a little
What is a?
clearer?
How is that the derivative?
A in here is, you can see it as one of two things. It's either the slope of that linear function, which is also the derivative of ax plus b. Okay, since it's a linear, it's a constant rate of change, so that's our slope. All right, let's try another one here with some trig. Okay? So, we are taking the integral of this with respect to x. Okay? Again, separating this so that it's 2 times the integral of sine of 3x dx plus the integral of cosine of 4x plus pi with respect to x. That'll be helpful. Okay? So again, now we're looking at the integral of sine. What is the integral of sine? Negative cosine. Good. So there's our negative cosine, and notice the inside is going to stay the same. It's still the negative cosine of 3x. But how do we account for the 3x? Very good. We're going to multiply by a 1/3.
Why?
Because that is the a.
Oh, you're that.
Okay? So we've got that. Plus, what's the integral of cosine? Sine. So it's sine. Color's going. Sine of 4x plus pi times 1/4. Very good. Times 1/4. All right? Because again, 4 would be the derivative of that inside function. Okay? So, simplifying this, we have a negative 2/3 cosine of 3x plus 1/4 sine of 4x plus pi plus c. And that's it.
Or negative 2/3. Oh, this is negative cosine.
Mm-hmm. All right. Now, one more thing, one more example I want to use, and that's because there's an element to this that will hopefully make you maybe appreciate some of the trig stuff that you did back in pre-cal honors. Okay, all those identities that you had to learn. Those identities and a lot more are used to help us at times integrate things that otherwise we wouldn't be able to integrate. Okay? For example, if I'm trying to find the integral of 2 minus sine squared, okay, I can't integrate that without using an identity. They give us an identity to use here. Okay? And the reason is, you might say, well, I'll just use the rule we just learned. But this is not a linear function inside of here. This is a periodic function. Okay? So we can't use the rule we just learned with the 1/a thing. Okay? So your next thought might be to do what?
Split it up.
Okay, yeah, let's FOIL it out. All right? So we have the integral of 4 minus 4 sine of x plus sine squared of x dx. And the nice thing about this is I actually am able to integrate part of it. The integral of 4 is 4x minus 4 sine. That's going to be minus 4 times the integral of sine, which is... Very good. So it's plus 4 cosine x. The problem is, though, we don't have anything for sine squared.
Why can't you just do negative cosine squared?
It doesn't work that way. because you have a function inside a function here. Okay? There's no chain rule, there's no product rule, there's nothing like that for integration. So, this is where this identity comes in. Okay? Now, there are whole books full of different trig identities. Okay? Here's one that, notice, takes a sine squared and creates a cosine of 2x out of it. All right? This is actually derived from your double angle formula. Remember, cosine of 2x equals 1 minus 2 sine squared of x. Okay? All they did here was solve it for the sine squared. Okay? We subtract 1 and then divide by 2. Cosine of 2x minus 1 is a negative 2 sine squared x. So we divide everything by a negative 2. And sine squared is a positive 1/2 minus 1/2 cosine of 2x. All right? So they took an identity that we learned in the past, they modified it, so now we can actually use it here. And all this is still just waiting to be incorporated into a final answer. But now we have the integral of 1/2 minus 1/2 cosine of 2x. Okay? So, what's the integral of a half? What? What's the integral of a half? 1/2 x. Okay, it's a constant, right? So just tack an x onto it. All right? Minus 1/2 times the integral of cosine of 2x. All right? What's the integral of cosine of 2x? Sine of 2x times a half. The derivative is negative sign, the integral is positive. So, times a half. All right? So here's the minus half that was right here. Okay?
What would be minus half x?
What?
Or no, because it's attached to the cosine. Why isn't it minus 1/2 x?
What do you mean? Well, you have a plus 1/2 x because that was a positive 1/2.
And then why do you?
This is just a constant multiple. So you just write down the constant multiple, figure out the integral of the rest of it, and just multiply it. Okay? So now we can give a final answer. Here's 4.5 x. So 4.5 x, or 9x over 2 if you want, plus 4 cosine of x minus 1/4 sine of 2x. Okay? So there's an example where we're able to use an identity that's just an alternative form of an older identity we know in order to integrate something that otherwise there's no way to integrate that without, using some kind of summation or trapezoid method or something crazy like that. And to do that, you'd have to have a definite integral anyways, so. Okay, does that make sense? Yes, plus C, thank you. Forgot the plus C.
10 push-ups. 10 math-ups.
All right. So, at this point, here's what I'm going to have you do. If you look at the PDF, it's already up online. You'll see practice 3, 4, and 5. Okay? You may want to even just start with 5 because those are just very straightforward find the integrals. And then these two are more problem-solving types. We're going to do more practice tomorrow, okay? It's all in the same PDF, so you can stop when you get to here. We're going to look at those tomorrow, okay? I'm going to give you the remainder of our time here to begin practicing with this.